Alrighty, so this time we're going to be looking at two lots of triangles that have a missing value in the denominator this time, and on the bottom of the fraction. Okay, and I kind of spoiled the surprise there, but nonetheless we're going to have a go at these ones and see what we come up with. So hopefully you guys start off by writing down your mnemonic or whatever that thing's called. Socotar, top of the page, nice and big. Well, not too big, but big enough so that we can see it, so we can get started. Okay, let's have a look at this first one. Now the first one, 33 degrees is our missing angle, or our known angle in this case. We've got 21 meters on the right hand side there, and our hypotenuse, which I'm going to start off by labeling, is x meters there. Okay, so we don't know what the hypotenuse is. We do know which side though. Well, it's the opposite across from the 33 degrees. So it's our opposite side, and our adjacent. We don't know anything about our adjacent. We don't want to know anything about our adjacent, so we're going to ignore it, okay? So we only want to put our letters near something that's already there, okay? So if there's nothing there, we don't care. There you go, little rhyme. If there's nothing there, we don't care. So let's go through and solve this one, okay? Which ratio uses O and H? So looking back up our mnemonic, hopefully we spotted the SO, the sine opposite adjacent. So I'm going to go in and write out my formula. Sine theta is equal to opposite over hypotenuse, not adjacent. My bad. So sine theta is equal to opposite over hypotenuse. Okay, so let's go through and now solve this by substituting in the values that we do know and the missing pronumeral that we're going to find. So we know that our angle is going to be 33 degrees. Okay. Now our opposite side this time is equal to 21 meters. Okay, so 21 is going to go there, and I just stop banging my Apple Pencil. And our unknown pronumeral this time is our x, which is going to go on the bottom like this. Now, there's a trick that we can do when it comes to solving these problems here when we've got our x on the bottom. Okay. Now, one way to do it, there's a few ways to do it. The way that I find easiest, and I think a lot of people find easiest, is if you've got the pronumeral, and this only works if you have the pronumeral on the bottom, okay, in these trigonometric problems. If you've got a pronumeral on the bottom, like this, what you can do is you can swap its position with that sine 33 degrees there. Okay, so let's swap it around, and it becomes x is equal to 21 on sine 33 degrees. Now, if you want to know why we can do that, I'll do a little, like a mini proof of why this works further, once we get to the end of the video. So once we do these two examples, I'll show you why this actually works. But I find that that's the quickest way to do it. We just swap those guys around, okay? And then we can just put this straight into our calculator as it stands, okay? So x is equal to 21 over sine 33. And I want to close the bracket off this time because I think, there we go. If I don't put the bracket in, it gives me a syntax error. So I want to close that bracket off. I'm going to hit equals, and it tells me my answer is going to be equal to 38.56. Okay, we'll do 2 decimal places. 38.56, and that's going to be meters. Okay, let's do the same thing for the other one now. Now, what you'll notice in this other triangle, okay, I might just zoom it in really quickly, is we've got a 50 degrees, and we've got this other guy over here. Now, in degrees, sometimes we'll have 53.5 degrees. We can have a decimal in degrees, but another way we can represent degrees, or, parts of a degree, is what's called minutes and seconds, okay? Now, what this here represents is 53 degrees and 40 minutes, okay? Now, minutes and seconds in degrees work exactly the same as they do in time. There's 60 minutes in an hour, there's 60 minutes in a degree. There's 60 seconds in a minute in both cases as well, okay? So 40 minutes in this case, if I was to actually round this to the nearest degree as it stands right now, 53 degrees and 40 minutes would round up to 54 degrees because 40 minutes is closer to 60 minutes than it is to 0, okay? So just keep that in mind when we're doing this one. But nonetheless, we still do it the exact same way. And we are still going to do it the exact same way. So let's substitute some values in. Okay. So we've got to work out what ratio we're going to be using. Okay. Well, here's my hypotenuse across here. There's nothing on the hypotenuse side because this is the angle. It's got an arrow, poorly drawn arrow pointing over here. So there's nothing on the hypotenuse side. So we're looking at opposites and adjacents. My opposite is over this side. So here's my O. And so that must leave my adjacent up this side. So the side that uses O and A, or the trigonometric ratio that uses O and A, is my tan ratio. So tan theta is equal to O on A. Substituting these values in now, okay, our known values. So we know that my angle, I might have to squeeze this in a bit. Well, I don't have to because I can just erase some stuff. But it's tan 53 degrees and 40 minutes. And I'll show you guys how to put this into your calculator once we get up to that step. So tan 53 degrees 40 minutes is equal to, okay, now my opposite is 71.3 over my adjacent. My adjacent value in this case, and your letter might be different when it comes to actually trying these problems. But for right now, it's my x value. Now, just like before, okay, because we have that pro numeral on the bottom, I can swap these two around. Okay. So swapping these two around, we get x is equal to 71.3 on tan 53 degrees and 40 minutes like this. And finally, we need to just substitute this into, well, not substitute, we need to put this into our calculator to get an answer. So to put in the minutes and degrees and minutes into our calculator, so we're going to start off by putting in our 71.3 fraction to get our fraction bar. And on the bottom, we're going to be putting our, I don't need that just yet. We need to put our tan in. Now we're going to put in our 53. We're going to hit our degrees button. Okay, we need to put our degrees button in this time. And our next bit, we're going to put in 40. So we're going to put in 40. And we're going to put in another one. Now you'll notice on the calculator, if you have a quick look, you've actually got like the open circle, which represents the degree, and then the single dash, which represents minutes, okay? Even though when it does its input, it only puts in one single guy here, a whole circle, it still represents the single like dash. And the seconds is represented by the double dash there. Close off the brackets, hit equals, and we get 52.44, and I believe that was centimeters, okay? And so those are our two values there. Now again, that's all you guys need to know how to do. There's going to be an associated worksheet for you to do with this stuff, just to practice these skills. If you're interested into why this flipping works, watch this little demonstration below, okay? And I'm going to do this with a number, because it doesn't just work with trigonometric numbers, it works with any number, okay? So let's say I've got the number 10, and I want to know 10 is equal to, let's say, 20 divided by what number? Now, you guys should know this. 20 divided by what is equal to 10? Now, hopefully you said 2, because if you didn't, there's a little bit of concern there. But regardless, 20 divided by 2 is equal to 10. So, pretty straightforward problem. So, the shortcut method, I said before, was to just swap them around. And that still works in this case. So if I swap this guy with this guy around, we get x is equal to 20 on 10. And 20 on 10 is just 2. And that's true. 20 divided by 10 is equal to 2. Okay, but why can we actually do this? Like, why can we do this swapping? Well, it basically stems down to the fact that we're going to multiply both sides by this x value and then divide both sides by 10. Okay, so we're going to pretend the x was just a number. Like, say it's the number 5. Okay, we don't know what it is. Pretend it's the number 5. Well, we do know what it is, but we're going to pretend we don't. Okay, let's multiply both sides by this x. So that is, I'm going to multiply this side by x, and I'm going to multiply that side by x, okay? On the left-hand side, I get 10 times x, which is just 10x. And on the right-hand side, I get, 20 over x times x, which is the same as 20 over x times x, okay? Which is the same as, I could rewrite this as 20x over x, okay? Because when you multiply fractions, x is the same as x over 1, so it's like 20 times x over x times 1, okay? And when you've got this 20 over x, okay, on over here, 20x over x, the x's cancel out, okay? Because x divided by x is just 1, okay? So conveniently, on the right-hand side, the x's cancel out, and we're left with 10x is equal to 20. Now, what we're going to do is we're going to divide both sides by 10. So we're going to divide this side by 10. We're going to divide this side by 10, okay? And so what that leaves us with is x is equal to 2, essentially. So what have we actually done? Like, let's think about the movements that we've done now. So by timesing by 10, I've essentially moved this guy. I've eliminated him from this side, but I've moved him up to here. Then by dividing by both sides by 10, I've moved this guy from this side, but I've put a 10 from here down to the bottom. I've essentially just done this switch, okay? By multiplying both sides by the bottom and then dividing both sides by the left-hand side, I've effectively done this switch. Now, this is why we can just do it in one step, because it's the same sort of idea. The only time you can't do this is if you have something along the lines of, like, say you've got, x plus 5 is equal, x plus 5 is equal to, like, say, 3 over x, okay? You can't just go, oh, well, let's swap the x and the 5 around. You can't do this. No, bad. Can't do that, okay? So it only works when you've got those single numbers, okay? That one number by itself, okay? And basically that's all we need to know in that regards. But realistically, you don't even need to know that that's the case as long as you know that trick that you can just swap them around like this. So with that being said, guys, that's the end of this video series. As I said, there's going to be a little worksheet that's going to come up with this just for you guys to practice doing a little bit of trick. Okay. So with that being said, hopefully I'll get to see you guys soon and enjoy.